Hey you, so as you can see, I got evicted from my office again, so we're back in the sunroom. Not a beautiful day, okay day. So now you know everything you need to know kind of about the logic of capacity calculation. We went over a tier of constraints, a little bit more of logic and the steps. And now we're going to go into an example of how to calculate. Yes, that's where the fun begins. And also in class, we're going to do a problem where you have to, try to calculate the capacity. So now I'm going to show you it is there are a lot of steps that you need to follow. Keep that in mind, take notes, and in class, we're going to do one together. Okay. So take a look at this urgent care example here. We have these process steps A, B, C, D, E, F, and G. First is registration. So you have the task time here of 5 minutes with 20% rework. You have checking vitals 4 minutes, 10% rework. Exam 10 minutes, 5% rework. And you know the work content you just multiply by 1 plus the rework, right? So 1.2 multiply by 1.1, multiply by 1.05, and you get the work content of that activity. Uh, so here we have two steps that are done at the same time, X-ray test and blood test. And for a capacity calculation, it doesn't matter if they're doing it the same. Well, it does matter if they're doing it the same time, or if there's part of the items go one way or the other. The difference is that if they go to two at the same time, we're just going to go 100% up and 100% down, right? And kind of I'll explain how it works if some of them go up and others go down, how that works. Okay, later on. So don't worry about that now. So I'm going 100% up, 100% down. Then I have the second consultation here, and then at the end we have the checkout, right? So we know how to calculate flow time in this example. Are these activities in parallel or alternate path? So parallel, right? Because they're going at the same time. Now we want to know how many I can do in a day, right? A full day of operations. What is the capacity of this process? To do that, I need to create a table like this one where I have the activities here. And you guys have an Excel spreadsheet that you can download on Blackboard with this table so you can follow, or you have that also in your notes so you can take notes there and write down what are exactly all those things. So here we have, you only have one big table in your Excel spreadsheet and kind of divide it here. So it will kind of make more sense to explain. So we have the activities here, the absolute time for each one, the proportional time for each one. It means that if I'm going, every product is going on that flow, it will be one. If I have a flow where 30% of the items are going that way and 70% are going the other way, then that's the proportional time, 0.3 and 0.7, for example. Or if 50 going one way, 50 going the other, then I multiply the proportional time. That's why this column is there. But here I have a parallel path, so it's all 100%. We have average time per visit, which is just using this, multiplying this by this. So this is a formula. Greens are the values that you have to input, and the non-greens are formulas. Average visits, so that's where I put that multiplier for rework time, and then I have the work content of the activities, which was already on the other file there, right? So you guys know that, just multiply, know you can do that, pretty easy peasy. So this is the new one, and until here is the same as the flow time. Here we have the resources, right? So we need to figure out who's doing what, right? Who is doing what in all this mess. So you can put a letter there. That's what I did. It makes things easier. But you need to find out what the clerk is doing, what the assistant's doing, what the doctor is doing, because these are your resources. And the resource can be a bottleneck, not an activity. Activity is not a bottleneck, a resource is. So here you have C for clerk, N for nurse. Then you have N and D when there's two of them at the same time, X for X-ray lab, and so forth, so on. Okay. Okay, so it could be a machine or a person. And here is your pool. So in another table below, you have the resource pool, the clerk, nurse, doctor, X-ray, or lab. Here is how many people you need. So not you need, you have. How many people you have currently in your system. And here's the load batch. So load batch is very important. If you forget about that, you're going to miss a lot of capacity. Some equipment can do a bunch of things at the same time, right? So basically think about an oven where you can, bake a lot of cupcakes at the same time, right? So you have to make one cupcake at a time. So the time will be per one, but then when you put in the oven, it takes 20 minutes. When you get out, all of them will get out at the same time. So that's the load batch, right? And that's happened a lot in manufacturing and service industry. So you have to be mindful of that, okay? So the load batch is here. How many you can do at the same time? So it takes, let's say the lab, it takes 66 minutes here for a product to be done, but every time you have something done, you have 20 done. If you don't have one done at every 66 minutes, you have 20 done every 66 minutes, okay? Then another thing that we need to calculate is the net availability. So basically, you know that you have 3 nurses. Well, how much time they are available? So because it's all about time, right? It's all about how much you can produce in a certain amount of time. So that table is just calculating how much time you have in a day in each resource, per one resource. And then you're going to multiply everything by the name of resources, and that'll be easy as well. So the net availability that's the problem have to give you, right? So the problem gave us 600 minutes, which is 10 hours that each clerk works, or nurses, and blah blah blah. Some breaks. The doctors have more breaks. I know it's unfair, but they do. They have a lot of advantages. And the X-ray and labs has some other breaks that are not, physiological breaks. They're maybe cleaning or whatever it is, setup, whatever it is. So then you have the net availability here. That's how much time you actually have, right? Because you're taking out the breaks. And the table Excel spreadsheet is just showing the 525. And now you need to calculate what you call the unit load. So the unit load is very important. It is how much time I'm going to use of that resource, okay, per patient or per product. Because one resource can do multiple tasks. So you have to combine those tasks and put all those tasks together to calculate how long it will take. For example, the nurse can do, the 2 or 3 steps. So you have to add those steps together and say, okay, I need this amount of nurse time. Okay, and that's what this is doing. It's just taking, here you have the letters from, not the resource pool letters. These are letters from activity. So that's activity A and activity G that is done by the clerk. So if you add them up, and they were here. So you should take A, which is 6, and G, which is 3.3, right? G and A. You're adding everything you need from a clerk, and the same thing for all the others. Okay? You're adding them up if you need more than one step associated with a resource pool, because that's the table that's given the capacity. So the table that's giving the capacity is not based on activities, it's based on resource pool. That's, you have 2 tables, right? In your Excel file, you have a table per activity, because you need the total word content there. You pick that word content and you put in the other table, which is the table per resource. And the table per resource is the one that's going to give you the capacity, okay? Which is this one. So here we have this stuff that we cover B, C, and D we covered, and now E we covered. So we only need to do the math, and we're good to go. So the capacity, here we have the formula, which would be F. It's B times C times D, so B times C times D, okay, divided by the E, which is the load. Okay, so load is how long it takes from one unit, and you're basically multiplying the time by the batch by how many you have. Okay, and you divide that by the unit load time. And what this math will give you is the capacity of each individual resource. Okay, so pay attention to that. I know that I can. My clerks can process 169 patients. My nurse is 53. My doctor's 48. My X-ray 147, and my labs can process 463. Okay, so what is the capacity of this process, right? All the process together. How many patients my urgent care can process? Well, if you watch the last video and pay attention and took notes, you know that we need to use the theory of constraints, right? And the theory of constraints is going to tell us that the lowest one is the bottleneck. So the bottlenecks are the doctors here, okay? So here I have the same table. The bottlenecks are the doctors, okay? Because they can only process 48. And the other ones will have wiggle room. The other ones will have extra time that they're not being used. So to calculate that extra time, I need to calculate what you call the utilization, right? So the last column, I think. Utilization is going to be bottleneck capacity divided by the capacity of that process. So if you were fast enough, you notice I just corrected this math was wrong before. Now it's right. So 48.29, which is the doctor's capacity divided by 169.36, which is the clerk capacity, will give me the utilization. And you can see some processes have a very low utilization, like the lab, because it can produce a lot more than actually the doctors can. And some of them have a very high utilization, right? The nurses. And the doctors have 100%. Why? Well, because they are the bottleneck, right? So the bottleneck will be the process with 100% utilization. Okay, I'll correct the material. If you downloaded before I corrected, just figure that out and correct it by yourselves. Okay, so my total max throughput time, max capacity is 48 patients per day.